Good morning. My name is Om Patil of class 9 and I am studying in KD Society's English medium CBC school Nipani. So today I would like to showcase my project. But before that, I would like to tell you a fact. Did you know 1,000 lives are lost every year because of natural disasters? It's not because we lack technology, but it's because the alert systems which are implemented in these areas are either too slow or they're too expensive. So I have made a project which is both fast and affordable. So the name is ESP32 Disaster Alert Management System. So before that, explaining the project, I would like to tell you the main problems. The problems are natural disasters come without any issue or they come without any notice. That means they come whenever they want. As you can see in the Myanmar earthquake in 2025 and then the Afghanistan flood in 2025 which happened in the early November. So because of these millions and thousands of lives were lost. So and the thing is the sudden temperature and humidity and the thing is these disasters can be detected but the governments and the people are not taking and they are not detecting and there's been a loss of casualties. So he must be thinking, okay, so he has prepared a project, a model. So what are the components that he use and what is the system architecture? So the components used are an ESP32, which is the brain of the computer, which kind of looks like this in the photo, and you can see here. And then we have an OLD display. It displays all the reading sensor data onto this. Then we have SW420 sensor, which you can see is a vibration sensor. That means it detects if an earthquake is coming or not. Then we have a DHT11 temperature and humidity sensor, which means it tells us both the temperature and humidity. This is very essential. You must be thinking, why is it essential? Oh, it is essential because cyclones, tornadoes, hurricanes, tsunamis, not tsunamis, but the thing is, these happen due to the fluctuation of temperature and humidity because the rise of cold air and the downfall of rise of hot air and the downfall of cold air. So now we have come on the ultrasonic sensor, which is my favorite part. The ultrasonic sensor has a radar, and the principle of the ultrasonic sensor is and it sends sound which vibrates at 40,000 hertz. This may be surprising, but it travels there and comes back. And when the sound comes back from the transmitter to the receiver, it calculates the distance which it has taken, actually the time, the distance and the time. And mostly when it calculates the time, it displays the distance by using the speed of sound. Then we have another ultrasonic sensor which is here, which is the flood detection system. The flood detection system also works like this, but it is just stable. That means, as you know, waters aren't going to move around like hurricanes. So if a water rises above the predefined thresholds, it will detect and tell us. So now I have explained you both the components and system architecture. So now I'd like you to explain the features. It sends real live data for everyone. The major problem or flaws of other alert systems are the people of that country, locality cannot access such data. They are removed from the accessibility. So my aim was to provide them access by providing a live web server, which I will show you later. Then I have a high-end web server, which I've told you. To access this, there needs to be some form, some code, and some sensor reading by which they can access. And the live web server facilitates that. Then it's low cost. I mean, it is cost efficient. The cost efficient means that it can be set up almost everywhere in the country under a budget. So the government of India doesn't have to spend that much. Then it has wireless data transfer. I mean, they transfer data wirelessly from the ESP32 or server to the laptop or any other phone or even your phone for reference. Then it can function 24/7. That means it also has a backup battery and a charger. So it is a solar powered battery. So in the day it can charge and use that energy, and at night it can store that. After the storage of that energy, it can use that connected chemical potential energy to convert that into electrical energy by which it can use whole day. So now the last part is it is easy to assemble. That means it is cost efficient, affordability, and the deployment can be easy. So now I have told you about my system. I'd like to tell you about the working model. So the working model, so first of all, you can turn this on. all the data gets on. This connects to Wi-Fi. As you can see, it is showing connected to IP address. This indicates that this turns on for 3 seconds to indicate that it has turned on. So now I would like you to show you the live web server. See, now everything is set. So now the thing is, it is connecting to the same Wi-Fi. So it is a local web. But I can show you. Now I will reload this page or the IP address which I showed you earlier. So now as you can see, this is a monitoring system or a web page which I told you earlier. And it sends live data. That means, see, hurricane radar. It can send the radar and by which it can detect objects. Then the flood sensor, which is showing the second sensor behind, which is showing the distance from the flood to there. Then, as we know, we have temperature and humidity, which I can show you the change of temperature. You must be wondering. So now I have taken a lighter and now I'll turn this on. Oh, and yes, this is a practical example of the SW20 sensor. So as you see, I accidentally shaked it and it detected the slightest vibration. And by detecting the slightest vibration, it was able to identify that there was a coming earthquake. So now I would like to show you the temperature and humidity. As you can see here, it will take a little time, but you can see the fluctuations. Now I have turned this lighter on. It shows here instantly the change of temperature. As you can see here, now it is showing 30. And yes, because of the extreme rise of temperature, it has shown. And now it has turned from 29 to 29.5 to 2030. So that was a practical example of the DHT11 sensor. And here is the radar. If an object comes in between, as I put my hand here, see, it can detect an object is between it. So it can alert the people and it can alert the staff associated with the government organization. So now say my hand is a water and it's coming here. Say it comes and rises from the predefined thresholds. And see, as it enters the predefined thresholds, it activates the alert system and you can see flood tsunamis, and if you can see here, the background has turned red. I will show you once again. You can see from blue the background has turned red to indicate that there is a natural disaster and we should evacuate. So now it can also display the alert status here also, and there's also refresh data now. And if you connect to my hotspot, you can see this live data live in person. So now, this model is a message to the NDMA, this is a message to the NDMA, National Disaster Management Authority, by which and in IMD, which is the Indian Meteorological Department, which detects both disasters, evacuates people and the things. And this photo exactly represents what my model can do. It can detect floods, tsunamis, hurricanes, earthquakes and wildfires. So at last, this isn't just a prototype or a model. It can detect the earthquakes in Uttarakhand, the floods in Kerala and the wildfires in Maharashtra. So this was my project, ESP32 Disaster Alert Management System. So if you have any doubts, please ask me. Bye.